for this lesson, we're going to be talking about something that we're going to be seeing a lot this chapter, and that's proving something that's happening. A lot of times this chapter, you're going to have to draw a conclusion based on what is given to you. And it has to do a lot with your information that you already know, like your vocabulary words. So the first one is that I always look to see for at the given. So it says B is the midpoint of AC. So that's our statement. Our first statement is B is the midpoint of AC. And the reason we know that is because it's given. Now, what is a midpoint? A midpoint takes this segment and cuts it into two congruent parts by the definition of midpoint. So every time we are given a statement, you need to come up with a congruency statement. So that's our second statement. So here we would say AB is congruent to CB. We know that because a midpoint states that it cuts a segment, we'll say AC, into two congruent parts. So midpoint states that it cuts AC, its segment, into two congruent parts. Okay, so anytime you're given that something is the midpoint, you can say that, well, whatever it's in between, it now has two congruent segments. Here we have LE, ray LE, bisects angle BLU. BLU is this big one here. So our statement is LE bisects angle BLU, and that's because it was given. We know that because I gave it to you. Now what that means is that you're going to take these BLU, and it now has made two congruent angles. So you've just come up with your congruency statement. Angle BLE is congruent to angle ULE. And we know that because bisect means cut into two congruent angles. So I gave you a piece of information and you came up with something, a congruency statement, based on the information given. Here's another two. In this one on the left here, do you see anything that's given? As in, do I give you a statement? I don't. But what can we conclude? If ever you have two lines that are crossing, you always have vertical angles. I'm going to label this 1 and 2 because there are no angle points to name it. So what we can conclude is that we have vertical angles. So we can say for statement 1, angle 1 is congruent to angle 2, and the reason behind that is vertical angles are congruent. Now in the second one over here, we have given AB is perpendicular to CD, so that's the first thing that we write down. And we know that because it's given. Now that's not a congruency statement, so we have to somehow come up with a congruency statement. So AB and CD are perpendicular, which means they form right angles. And what's true about right angles? They only have one measure. So we can say angle ADC is congruent to angle BDC, and the reason behind that is all right angles are congruent. So notice we always started with the given statement, and then we came up with a congruency statement saying that two angles or two sides are congruent. So here's another example. What this has is it actually has a missing side. So if you could draw in the line from S to U. So here we have CU, given CU is parallel to BS. and the reason is given. Now, that doesn't say that CU and BS are congruent. It just says that they are parallel. Now, if you think back to a couple chapters ago, we talked about parallel lines and what happens when you happen to have a transversal, meaning SU, cutting through them. Whenever you have parallel lines, your angle pairs can come into play. So here we have a pair of alternate interior angles based off of two parallel lines. So we can say angle 1 is congruent to angle 2 because alternate interior angles are congruent. Try your homework. If you have any questions, come see me in the morning.